Hello, welcome to Mr. Lamb Science Corner. It's been a while, I know, and sorry about that. There have been some reasons for that. Um, we're going to do things a little bit differently for at least some of the things uh, that we're going to do. We've been doing demonstrations in science and math games and math topics. Um, Someone asked me if I could do some chapbooks on chemistry per se, and I thought, well, I'm not really that much of a writer, but maybe I could do chat videos instead. And I thought I could start with mostly with elements and just walk you through all 120 elements one at a time, and then um, uh, pick other topics, people involved in chemistry and chemistry topics, and just kind of a mishmash of a little bit of everything. So hopefully you'll enjoy this. To retell you what we had before, um, I was I taught for the most part high school this and that math and science, and I had to retire due to cancer, and then I got a little bit better, and I was asked to do Starbase um, for a while, and then I got cancer again, and it's been ugly, but I'm feeling much better now. And Starbase, if you don't know, is a Department of Defense program. You have to have a military base somewhere close by. And here at Klamath Falls, we have Kingsley Field. And um, in Oregon, we have Kingsley Field and we have Portland Air Base. And those are the only two places that could possibly have a Starbase. They both have a Starbase. Not every military base has a Starbase, so if you have a military base within your area and you teach fifth grade elementary school, then it's something you may want to get involved in and get started. Uh, Starbase is a science and math week-long program. It's very, very good. I strongly recommend it if you can. The problem is that here in Klamath Falls, we can hit every fifth grade class that wants to show up, and that's a good thing. Uh, we have, with the year I taught there, we had public schools, private schools, we even had home-based schools, and homeschooled students, and that's great. But in Portland, it's a much bigger town, and they're running three classes at a time, and they can't get but half the students because everybody wants, it's such a good program, everybody wants to do it. So they asked me as I was leaving if I could find the time to do demonstrations for those teachers who couldn't get into Starbase. And so I thought about it and I thought, yeah, I could do that, but I wanted to expand it beyond just for teachers, for parents and grandparents. The Starbase, the science demonstrations were for adults to watch, learn how to do, practice them, and then do them for the kids. And put in, because I tell people I'm not Bill Nye the Science Guy. You would never come close to that. Um, and the kids expect a lot of flash. And I don't really do flash. So I thought I could teach the parents how to do it. They can put in the amount of flash that they want to. Uh, Keeping safe, of course. So anyway, this is with the elements and with the other topics. I would say I'm going to try to aim it for roughly middle school and up, and so uh, it's for the if the parents want to watch it and then talk to their kid about and sound really educated about the elements, that's wonderful. If you want to have the kids watch it, that works too. And so it's open basically to everybody. And of course, it's on YouTube, so it's free, which hopefully is a good thing. So anyway, that is what we're going to do. The topics, we're going to look at atomic notation. And a real quick little thing here is that one thing you need to know is that there's a difference between something called mass number and atomic weight. Okay, so we have these two topics, mass number and atomic weight. Atomic weight is an average. And if you think of something like a GPA or something like that, you have grades. Now, I understand that not all school classrooms do this, but most places that I've seen will do A is 4 points, B is 3 points, C is 2 points, D is 1, F is 0, and they don't give like F minuses or A pluses or anything like that. Or if they do, they still count it the 4, 3, 2, 1, 0. So you take all these grades you get, and then they average them into a GPA. So they take all the 4s and 3s and 2s and whatever, and then add them together and divide by the number of classes, and they get a GPA. So the atomic weight is very much like that average. You take a natural source of the element, say chlorine, let's take it as an example, and you find what its atomic weight is. That's the average. A mass number does something a little bit different. It's related to the atomic weight, but it's a little bit different. And to know that, you need to know that the mass number is composed of protons and neutrons. We spare no expense to bring you the high quality material. Okay, so protons and neutrons both have a mass of approximately 1, and it's close enough to 1 to where we're going to define it that way. So any proton you see is a mass of 1, any neutron you see is a mass of 1. And you add up all those numbers, and then different, something called isotopes. I know I'm getting a lot of new terms here, but these are things you've heard of, hopefully. And an isotope is a different flavor of an element. For example, hydrogen has 3 different flavors. They all have 1 proton. That is how we define an element, is by the number of protons it has. And what makes a difference is how many neutrons it has. Most hydrogen have 0 neutrons. Some hydrogen has 1 neutron, and very, very few have 2 neutrons, making a mass number where we add them together of 1 plus 0, 1 plus 1, 1 plus 2, so we get mass numbers of 1, 2, and 3. And for hydrogen, that's enough difference to where we actually name the different isotopes by name. We call it protium, deuterium, and tritium, and you may have heard of those because tritium is used in the production of hydrogen bombs. And so you might have heard of tritium in that. And also there's some other tritium devices that we use because they give off a steady source of energy for some time. Okay, so the mass number is an important number. We always name the element from the number of protons. So chlorine is 17, and oxygen is 8, and things like this. And then we also get there. So we'll stop there and let you digest that, and then we'll go on to the second video, which is going to talk more about protons and neutrons. Thank you.